In this lecture, we're going to take a closer look at how communication on a Modbus network takes place with a single master and multiple slaves. We will do this by introducing a new concept called the Modbus Unit ID. Again, let's look at an example. In this network, we have one master and 3 slaves. Now, on networks of all different types, not only Modbus, it is necessary to be able to uniquely identify each device connected on that network. How this is done is that each device is given a unique number that acts as a numeric unique identifier. A Modbus network is no different. Every device on a Modbus network must have a unique number assigned to it, and that number acts as its address on the network. Each device on the network can therefore be uniquely identified by this number. In the case of Modbus, the unique identifier is a number ranging from 0 to 255, and is called the Modbus Unit ID of the device. But how do you exactly assign these numbers to the different devices? Well, almost all Modbus compliant devices will come with some programming software that you would need to install on your computer. The programming software will allow you to set the Modbus Unit ID of the device. So before you connect a Modbus device to the Modbus network, you need to use the device's programming software to set its Modbus Unit ID. The Unit ID would then be permanently stored in the memory of the device. Now, why do we need a Modbus Unit ID to uniquely identify each device on the Modbus network? Well, it has to do with how messages are sent back and forth on the Modbus network. Let's look at an example again. We have our single master and 3 slaves. Now, here's a very important point I want you to take note of. In any Modbus network, when a device sends a message on the network, every single other device receives the message. In other words, all of them hear the message, so to speak. This may seem kind of strange, but that is how it is. It's almost like a broadcast. So let's say that the master PLC in our example wants to send a request for a data value to slave 2, shown here. So it needs to send a request message to slave 2, and then slave 2 will respond with the data value. So we have used the necessary programming software and have set the Modbus unit IDs of all of the devices on the network. The unit ID of the master is 10. The slaves are 21, 22, and 23. When the master sends the request message out onto the network, all of the slaves receive it. But what the master does is that it embeds the value of the Modbus Unit ID of the slave in the message. As you can see, that's 22. It wants to address 22, so it embeds the value 22 in the request message. As we indicated before, all of the slaves will receive the message. But here's what each of them does. What they do is that they pull the message apart when they receive it, every single one of them. They get the Modbus Unit ID of the message and then compare it with their own stored Modbus Unit IDs. It is only if the received ID matches their internal Modbus ID will they respond. So in our example, since it is only equal in the case of slave 2, it is the only slave that responds. Slave 1 and slave 2 simply don't do anything at all. So slave 2 will respond with a message back to the master. So this is why each device on a Modbus network needs to have a Modbus Unit ID. The master on the network depends on it in order to single out any device to communicate with. This is one of the most important concepts in understanding Modbus. It is also very important to remember when we begin our look at RS-485 later down in the course.